Hello students, welcome you all to the video lecture on signals and system. The question is find the Laplace transform of x of t equal to t e power minus at u of t. We know the Laplace transformation formula is given by x of s is equal to minus infinite to infinite x of t e power minus st dt. So here they have given that x of t equal to t e power minus at u of t. We know that u of t equal to 1 for t greater than or equal to 0, 0 for t less than 0. So therefore I can write your x of t as t e power minus at. What is u of t value? It is 1. Okay, and this whole value exists only for t greater than or equal to 0. Okay, so that is x of t in simple, it is t e power minus at for t greater than or equal to 0, or I can say the limit is 0 to infinite. Okay, so from these I can say that Laplace of t e power minus at u of t, right? How I can write? It is existing only from 0 to infinite. Instead of minus infinite to infinite, since u of t exists only for 0 to infinite, I have to write as 0 to infinite. And what is the x of t now? It is just t e power minus at. Why? Because u of t value is 1. So x of t you have written. So the rest of the items in your formula, it is e power minus st dt. Okay, so once you have done that, just write 0 to infinite as it is, t you have. Okay, so e power of, e is common for both the term. Okay, since in the integral you have infinite, right? So since here if you take e power minus t, when you substitute t as infinite, what happens? E power minus infinite becomes 0. Okay, suppose if you take t outside, then if you substitute your limit as infinite, okay, e power infinite becomes infinite. So you should not take t outside, you should take what? Minus t outside always. Okay, so in simplification always take e power minus t outside. So what happens? Here it is a, here it is plus. Why? Because I have taken minus t outside. Why I am taking e power minus t instead of e power t? Because e power minus t if I have, when I substitute the limit as infinite, it becomes 0. Okay, I should not get infinite value. Okay, so once you have done the simplification like this, now you can integrate this term. Okay, just integrate this term. What happened? So if you have only exponential term, you can directly write the formula, right? What is the formula? E power minus at, integration of e power minus at is e power minus at by minus a. But here you have additionally 1 t. Okay, so you have to apply the formula integral of u dv. What is integral of u dv? uv minus u dash v1. Okay, so here I have to consider the t as u and the rest of the term as dv, right? So here in this question u is a t and dv is e power minus t a plus s into dt. Okay, so in order to apply the formula, I have to find out v, v1 and u dash. So u dash means just differentiate this term. So differentiation of t is 1 and then dv is given. So from that you can determine v, that is integrate this term. What is v? Just integrate and write. So e power minus t a plus s divided by t's coefficient, that is minus of a plus s, and again in the formula I have v1 also. Okay, so if you have u and u dash, you have to differentiate this side. Okay, dv is given. In order to get v, you have to integrate this term. Again, in order to get v1, we have to integrate one more time. Okay, so v1 is equal to, here minus 1 by a plus s is common, constant term. Okay, nothing to do with that. So just integrate this term. So when you integrate that, minus e power minus t a plus s, again t's coefficient is what? Minus of a plus s. Okay, so like this you have. So now what is v1? Minus into minus will become plus. Okay, e power minus t a plus s in the numerator, and then a plus s the whole square. Okay, now this is your v1. So all the terms whatever you required in the integration you have determined. U is there, v is there, u dash is there, v1 is there. Now you can substitute in the formula. Okay, so this it is looking like u dv. So you are applying this formula. Okay, so what is u? So now we can proceed with the formula. What is u? It is t. Okay, what is v? V is e power minus t a plus s divided by minus of a plus s. Okay, so uv you have written. Then what is u dash? U dash is 1. What is v1? V1 just now we have determined like this. Okay, so e power minus t a plus s divided by a plus s the whole square. Okay, this is v1. Okay, and then since in the integral you have limit as 0 to infinite, in both after the integration just substitute your limits like this. Okay, now substitute your limits. Wherever you have t, just substitute your upper limit. Okay, so here it is infinite, e power minus infinite. Okay, minus of a plus s like this, right? And then substitute your lower limit. Well, while substituting your lower limit, minus into minus will become plus. Again t is 0, e power minus 0 divided by a plus s. Substitute here, take minus commonly outside, substitute your upper limit, e power minus infinite divided by a plus s the whole square. Why I am taking infinite as it is? Infinite into any value is infinite. Okay, substitute your lower limit. While substituting your lower limit you have to use one minus. Okay, then e power, wherever you have t substitute it as 0, e power minus 0 divided by a plus s the whole square, right? So now this value it is 0, e power minus infinity is 0, e power 0 it is 1. Okay, again e power minus infinity is 0, e power minus 0 it is 1. Okay, so anyway infinity into 0 is what? 0. 0 into any value is 0. Okay, and again here this term is also 0. Okay, so minus into minus is what? Plus. Okay, e power 0, e power 0 or e power minus 0 it is 1. So 1 by a plus s the whole square. So what are all the things we have observed? E power minus infinity is 0, e power minus 0 or e power 0 it is 1. Okay, also infinity into 0 it is going to be 0. Okay, so using all these things, okay, we have simplified and we have obtained your x of s. What is x of s? Laplace transform of t e power minus at u of t, which is nothing but 1 by a plus s, you can write it as s plus a the whole square. Okay, so this is your final answer for the given problem. Okay, thank you, thanks for watching.